Hello, good morning everyone. I am Teacher Renzo. Once again, welcome to our asynchronous day. So, happy asynchronous day to everyone, students of STEM. So, today we're going to discuss about the force and displacement and work also. So, according to the Newton's second law, summation of force is equals to the mass multiplied by the acceleration. So the acceleration of the particle is proportional to the total applied force. A large force does give a large acceleration, while a small force gives a small acceleration given enough time. Through a small acceleration can still produce a large velocity. So a large displacement, so there is a sort of trade-off between force and time. Our intuition tell us that a small force acting for a sufficiently long time can we have the same effect as a large force acting over a shorter time, but how long a time is required? The notion of work gives a way to answer this other similar questions. So consider a hanky pack of mass, or we written as small letter m, placed on a frictionless horizontal surface as sketched in figure 5. So this is our figure 5. Okay? So in our figure 5, when a force act on a hanky pack, the pack accelerate, we also say that this force does work on the pack. So the pack is initially at rest, and we want to consider how a constant force of magnitude force applied horizontally result for motion with constant acceleration from the past lessons that we have in chapter 2, applying equation 2.10 and denoting from the initial and final velocity by written of small letter v and sub of small letter I, and small letter v sub of letter small f. Respectively, we can written like this. Okay? Final velocity squared is equals to the initial velocity squared plus 2 multiplied by the acceleration of displacement. Okay? So where you can see this, the triangle, okay? It represents as displacement. So triangle with x, it's represent as displacement. So the puck starts from rest. So initial velocity is equals to 0. Okay? The initial velocity is equals to 0. Given the final velocity squared is equals to 2 times multiplied by the acceleration of displacement. So using Newton's second law, we also have F is equals to M multiplied by A, or force is equals to mass multiplied by acceleration. Putting it all together leads, or we written like this. So final velocity squared is equals to 2 multiplied by acceleration of displacement is equals to 2 divided by the mass multiplied by the mass times acceleration, and we also multiply by the displacement is equals to 2 divided by the mass multiplied by the force of displacement. So which we can rearrange to read. So force of displacement is equals to 1/2 multiplied by the mass and the final velocity squared. So in word, this result means that if we want to accelerate an object that starts from rest to a particular velocity, we can exert a large force over a short distance or a small force over a large distance. As long as the product of force and displacement is the same, the object will reach the same final velocity. The product of force displacement in equation 5.2, okay, this is our 5.2. So I can read the figure 5.2. which is the force act on the particle or this particle while the particle moves through a displacement. The initial displacement is equals to the final displacement minus the final displacement. The final displacement minus initial displacement, the work done by the force is given by work is equals to force displacement cost displacement. Okay? So, angle, you can see this, the zero that having a line inside. So, that mean is angle. Alright? So, we can written that, no? To solve that, we can written, or the equal of that is, we can written by this. So, work is equals to force of displacement cos of the angle. Alright? So, work is equals to force times displacement is equals to the Newton times meter, or we can write N point M. So, the unit of N times M is called joule. Alright? For the abbreviation of joule, you can write by letter J or big letter J. So, the definition of work given in equation 5.3, okay, only applies for one-dimensional motion in which a constant force is applied along the direction of motion. In 2 of 3-dimensional, we must consider that the force and displacements are both vectors. In this case, on 5.2, that you see before, the work done on the particle is written by this. Okay? So, where this is equivalent, or that is an angle between the force and the particle displacement. The factor of force in equation 5.4 denotes the magnitude of the force, while displacement is the magnitude of displacement. Okay? Through force and displacements are both vectors, work in a scalar. Also, W can be positive or negative or zero, and thus not have a direction. Okay? So, we have the key concept, the relationship between force, displacement, and work. So, number 1, work is done by a force acting on an object. Remember that work is done by a force acting on an object. The second one is the work depends on the force acting on an object on the object displacement according to the fast figure that you notice. Alright? The third one is the value of the work depends on the direction of force relative to the object of displacement. The fourth one is work may be positive, negative, or zero depending on the angle between the force and the displacement. Okay, the last one is displacement is zero when work is equals to zero, even though the force may be very large. So I have here a sample solution. Okay, but before we proceed to the sample solutions, okay, we have here the figure 4 that I say a while ago. So that is an example. The work done is towing car. This along a straight road in equal to force of displacement. So the example of 5.1, a towing car, a tow truck full of car of mass 1,200 kilogram to a repair shop several miles away as a part of a journey. The tow truck and car must travel on a highway, and when entering the highway, they accelerate uniformly as they merge into traffic. They have an initial speed of 10 miles per second when they enter the merge ramp, and a final speed of 30 miles per second. When they leave the merge lane and enter the highway, the length of the merge lane is 20 meter. Find out the work on the car. So I have here the solution. So before to calculate the work, we need to know the displacements of the car, the force on the car, and the angle between the force and the displacement. The displacement is equal to the length of merged lanes where areas the force is directed along the lane. Hence, the angle is equal to 0. In equation 5.4, we can obtain the force on the car from the acceleration together with Newton's second law. Alright, on the figure 5.4, show the problem the car that the tow truck have a constant acceleration along the direction of the road. The displacement and the force are both directed along the merge lane, and we can take as the displacement direction. Okay, to calculate the acceleration, we use the relation of pure motion with constant acceleration from chapter 2 that we discussed a while ago or last time. We denote the initial velocity as the VI, the initial position as xi from the equation 2.10. So we have here, as you can see here, the velocity, the final velocity squared is equal to the initial velocity squared times 2 multiply the acceleration multiply by the initial position or the final position minus the initial position. So the speed, the initial speed is given as initial velocity is equals to 10 meter per second, and the final speed as final velocity is equals to 30 miles per second. And the displacement during the time is final displacement is minus the initial displacement is equals to 20 meter. Solving the for the acceleration, we can get the acceleration is equals to final velocity squared minus the initial velocity squared divided into 2 multiplied by final displacement minus or subtract by the initial displacements, or we can write by this are 30 meter per second squared minus 10 meter per second squared divided into 2 times 20 meter. So the result is 20 meter per second squared. So we now use Newton's second law to find the force needed to produce this acceleration. We write the summation of force is equals to the mass times the acceleration, or we can write 1,200 kilogram multiplied by 20 meter per second squared. So it is when we can multiply by that, the result is 2.4 times 10 raised to the power of 4 Newton. Hence, the total force is equals to the total horizontal force, which we denote by force. The work done on the car is equals to the force times the displacement. So, force equals to the force, displacement equals to the final displacement minus the initial displacement is equals to 2.4 times 10 raised to the power of 4 of Newton times 20 meter. So the result is work is equals to 4.8 times 10 raised to the power of 5 Newton times meter is equals to 4.8 times 10 raised to the power of 5 joules. So notice that the unit of work is joules, or joules, or we can write letter J. So that's it for the discussion and for short solutions that I give to you for the force, displacements, and work. I hope you got what I'm saying for, and you got what I tell for. So that's it for today. God bless you, and I hope you enjoy and you learn from me. And for our activities, kindly proceed to our Edmodo activities folder and answer the activity that I provide for you there. Thank you and God bless you.